Today we're going to finish up a little bit of 10.1, which you guys did most of, so there's just a little bit left to do. And then we're going to review chapters 7 through 9. You have Connect Math 9.4 due tonight. Did you guys get my email about the weird wording on 7.9?
Yes.
Right, so it says it decreases, right? So if from today to next week, the money in my bank account decreases from here to then if I take what I have now and subtract what I have then, I have more now, I should have something positive. Do you see what I'm saying? But it says decrease, so it's greater than 0 because it goes down and it's larger now. So it's just a weird wording, right? It's that it decreases. The second one is decreased from the first one, which means that the first one is increased over the second one, is larger than the second one. And on the exam, I won't word it. I'll be more straightforward in my wording. But in real life, you will get some stuff like that. People will say stuff in that way all the time. So
I think that's the problem that made me think that it was always going to be the opposite.
right, and that's why I brought it up. Because it's not always the opposite. It's just that that one is worded unusually. Right? I will not word it unusually on the exam. So don't expect it to be unusual on the exam.
And there was one that said reject
that would be if there was one that says reject H naught, then that would be the one that would be where the claim is H naught. Yeah. Okay. So again, you can turn in lab 7 today. I will be here testing until 9:30. So just turn it in by then. For full credit. After Thanksgiving, the 3 classes after Thanksgiving, so last class we covered 10.1. The next 3 classes we're going to cover 10.2, 11, 1 and 2, and 3. 35% of your final is on those 5 sections. So those 4 classes, this last class and these next 3, 35% of your final is on there because exam 4 on those is rolled into the final. Does that sort of make sense? Which is worth twice as much as the other exam finalists. So you really want to make sure that you don't miss those 3 days because each one of those days is basically 9% of your final. If that makes any sense, what we're learning. So those are not ones, and I cover them very quickly, very simply. But if you're not here, you might, and you just study the book, you're going to do something harder or weirder or different, and that won't be very useful for you, I don't think. All right, you guys know the exam is on Tuesday, 11 o'clock. You can take it early if you like, tonight at 5 o'clock or 7:30 in here. Also, if you guys want, next Tuesday from 5 o'clock and 5 to like 9:30 or something like that, 9, that class is taking the exam tonight, so I have to be here, but I'm just going to have like sparkling cider and cookies and chips. If you want to come hang out, feel free to. I have to be here, but my students won't be here, probably. Some of them will, maybe. I have a review session on Monday, 12:30 to 1:30 and 6:01. So if you want to come to review, do so. All right, so let's take a look and go through chapter 1 very quickly, kind of just do a little bit of review and finish that up. How about Ishan, Gregory?
Second and learning objectives. Draw a scatter plot for a set of ordered pairs. Number 2, compute the correlation for coefficient. Number 3, test the hypothesis. Conditional equals. Conditional.
Rho. That symbol is rho. Spelled R-H-O. Rho.
Rho equals 0. Number 4, compute the equation of the regression.
Right, so don't draw P there. Don't put P equals 0 because P stands for proportion, right? And you don't get those confused. This is rho. It's like a loopy, weird P. It's an italic. It slopes and it just curls around. It doesn't have a little thing sticking up, right? Okay, and Riel, go read.
Introduction, correlation determines if a linear relationship between variables exists. Regression describes a relationship between variables that is positive or negative, linear or non-linear.
Rachel?
Scatter plots and correlation. A scatter plot is a graph of the ordered pairs x, y of numbers consisting of the independent variable x and the dependent variable y.
Great. So here example is a scatter plot. Things to note. Along the bottom is my independent variable, the one I can mess with, the one I have control over. And it should be labeled, cars. My range here has to go from the minimum, whatever my smallest x is, and make sure I cover what my largest x is. So think about that when you're doing your, when you're making these things. If it's 20,000 to 40,000, don't start at 100,000, at 0. Just start just to make sure you cover this. The y's, on the other hand, because remember that non-zero axis, because the y is your result, those do have to start at 0, because you don't want to have a misleading graph for a non-zero axis. So the y should start at 0 and go up. Good? Don't be like Fox News. All right. Andrew, go ahead and read.
Correlation. The population correlation coefficient denoted by
Rho.
is commuted by using all possible pairs of data values x, y, taken from a population. The linear correlation coefficient denoted by
R. That's just regular R.
is computed from sample data and measures the strength and direction of a linear relationship between two quantitative variables. The one explained in this section is called the Pearson product moment correlation.
Right, so I will give you guys a PPMC table after Thanksgiving, so you guys can work with this. But we have these things we're going to be comparing here. Is not necessarily our critical value and our test stat. It's going to be our PPMC value, which is, we're going to call it our critical value, but it's going to be from a PPMC table instead of a T table, and we're going to compare that to R. So as we go through this test, you'll see a test stat, you'll see I think a t-score. We don't use that. You go down and we use R. So we're going to use R because it's a lot easier to find it, or it kind of has more meaning. How about Kimmy? Go ahead.
Correlation. The range of the correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. If there is a strong negative linear relationship between the variables, the value of R will be close to -1.
Right? So again, +1 means that a perfect line with a positive slope. It doesn't know what the slope is, but it has a positive slope. It's a perfect line. A R of -1 means it's a perfect line with a negative slope. And 0 means there's no correlation whatsoever. And it's kind of helpful because 1 sort of looks like a line, right? -1 and +1. And 0 kind of looks like a big circle. So we're just like all dots everywhere. You know what I'm saying? So that's kind of nice that those sort of fit that really well. You guys did lab problem 3. And I think I believe I did my, I'll do it one more time. So this is my, so first, I'm just going to go through the steps. I'll go through the example again. The first step, hypothesis test, is your H0 and H1. The H0 here is always, always rho. Rho equals 0. The nice thing is H1 is always going to be rho doesn't equal 0. Very straightforward. So either there is, the first one says no correlation. Null is always no. In this case, no correlation. No relationship between the two variables. No line. This one, rho is not equal to 0, says there is a correlation. There is a line. So that's just all we're going to worry about. No line is a line. Step 2, we're going to use, with alpha, we're going to find the critical value from the PMC table. Step 3, you're going to put your x values in list 1, your y values in list 2, and then you're going to do stat, calc, lin, reg, t-test. Instead of doing all those long, complicated some of the x's, some of the x's squared, some of the y's, some of the y squared. We're just going to let you guys go straight to the Lin-Reg t-test, and that's going to give you everything. It's going to give you your a, your b, your r squared, your r, a whole bunch of stuff it gives you. You just have to scroll down a little bit. It's on that first screen. If you scroll down, your little button down, it gives you more information. The r is the very last thing it gives you. And again, we're not going to use our t value here. We're going to use our r value in this problem. Step 4, decide whether to reject h naught. So if when we do our critical value, we're going to have our critical value here, negative, and our critical value, the positive version. Because the PPMC table is always going to give you the positive one, but remember this is two-tailed, so you're always going to have the positive version and the negative one. If your test stat, it's the same as all the other stuff we've been doing. If you're in the shaded region, reject h naught, right? Because h naught says you're here. If you're sitting way out here or way out there, then h naught's not true. You're not in the middle. You're aligned. If you're here or here. Does that sort of make sense? This is our guideline for being aligned, way out there. So if you get something out here or out there, you're going to reject h naught, which means that there is enough evidence of a linear correlation. And pretty much all the problems we're going to do are going to be, or our claim is that there is a linear correlation. So it's always going to be, and support the claim of a linear correlation between blank and blank, whatever x and y are. So I'll go ahead and show you this one here. So here, this is the example we did at the bottom of the page last class. Cars and income. So the hypothesis h naught was, as always, what was it, guys? Rho equals 0. H1. So pay attention because you're going to be doing this in about 2 minutes. H1 is always going to be what?
Not equal to.
Yeah, rho is not equal to 0. Then find your critical value. Here's the PPMC table you're going to be using. You're just going to use the one off the sheet here for now. And remember, what's my n here, guys? 1, 2, 3, 4, 5, 6. Remember, we have 2 variables now. So it's n minus 2 because we have 2 variables. Before we've always only had 1. So it's going to be n minus 2. So my degree of freedom is 4, alpha is 0.05, right there, 0.811. That's going to be my critical value. So I'm going to find that right here, which is there. This guy's the one I want. So then you're going to draw a very nice little spot here, negative 0.811. And here's where negative 1 is. What's on this end over here? The very, very end?
Positive.
Positive 1. Yep, and 0's in the middle. So this is going to be positive 0.811. And then I'm going to find my critical value. So I'm going to I would put these into list 1, put those into list 2, and do stat test, Lin-Reg t-test. So how do you show your work? You write this down of L1, comma L2, and then you tell me what you put into L1 and what you put into L2. So that helps me out. So then you're going to get that your R is equal to 0.982. Where does that go? Over here. 0.982. So in this case, I would do what?
Reject.
Yep.
Reject.
It's in the rejection range. So step 4, reject H naught, which means that step 5, there is enough evidence. And like I said, these are always going to be support. So support claim, 98% chance. There's maybe a tiny chance that one of them on your homeworks might be the other way, but I don't think so. Claim that, claim of, we used to do that, of correlation. If you don't like the word correlation, you can put relationship, I don't care. between, what's my X? Cars, and what's my Y? Yeah, revenue. Cars and revenue. Good. Okay, you guys do, lab problem 4. Is it 4? 3? 4. Lab problem 4. Next page, yep. Yes.
I wasn't here last class,
Okay.
but can I?
Yes, you can. You need them also. Yes.
Oh no, I came last class, remember?
Did come last.
I mean, I came at the end and I got the notes.
Okay.
Yeah.
Got it. Right, you popped it.
What I got was on my sheet.
Sorry, people at home.